Okay, here are your notes for section 11.3. And you might already be thinking, what about 11.1 and 11.2? 11.1 and 11.2 are all about circles, and so is chapter 10. So I thought, let's put the circles with chapter 10, and we'll do that later at the end of the year. What is 11.3 about? Shapes, rectangles, quadrilaterals, mostly quadrilaterals. We are going to start with a rectangle. This part right here, I don't need you to draw it, and I don't need you to write it down. I just need you to understand it. So follow along, pay attention. Doesn't mean you just skip through the video because you don't have to write it down. Here's what will make all of the formulas make sense. To find the area of a rectangle, you've been taught probably a lot of your elementary life that it's length times width. We always call it the base times the height. And the reason for that is because it's not always the length and the width if you turn it sideways or diagonal or you flip it around. And it's also going to be related to all the other quadrilaterals. And whenever you talk about a base and a height, will always be perpendicular to each other. It only works to have a base and a height on triangles, rectangles, parallelograms, trapezoids, everything, if the base and the height are perpendicular to each other. So this rectangle area is base times height. Every shape from there on after can be based on rectangles or parallelograms, rectangles, parallelograms. And I'll show you why right here, starting with this parallelogram. A parallelogram looks like this. If we use length and width, we'd be like, is that length, is that width? No, we use base and height. So we need to call this the base, and the height has to be straight up. You can't use this as a height because it's slanted. And if you look at what happens to a parallelogram, if you measure its base and its height, I'll show you here, a parallelogram actually takes up the exact same amount of space as a rectangle does. The space is just rearranged. It's reorganized. So the formula for a parallelogram is also base times height. As long as you take the height perpendicular to the base. You can't use a slant. So all rectangles and parallelograms are base times height. We can pretty much make everything based off of a rectangle or parallelogram. Here's a right triangle. Again, you're not drawing this, you're just following along. Here's a right triangle. Where's the formula for the right triangle? Well, a right triangle is exactly half the size of a rectangle. So where does that formula come along? The area of any triangle is half of a rectangle, half of base times height, because you would need two of them to make a whole. What if it's not a right triangle? What if it's just an equilateral triangle, isosceles, scalene, doesn't matter? Okay, it's still going to be exactly half as big as a parallelogram. But we know that a parallelogram is also base times height. So we would have to take that base times height and cut it in half. What would we do for a height of this? We'd have to measure straight up through the triangle at a perpendicular. This one we already have a base and a height because we already had a perpendicular. So everything is going to be based off of a rectangle or a parallelogram, including triangles. How about a trapezoid? Just a plain old trapezoid or an isosceles trapezoid? You're thinking, how in the world am I going to make that into a rectangle or a parallelogram? Watch this. If I cut it in half, chop it off. Take this top, put a little nail right there, hinge it. I'm going to spin this around and end up with it right next to the rest of it. And I think I had yeah. So if you cut it in half, spin it around, a trapezoid, an isosceles trapezoid, takes up the exact same amount of space as it would if it were a parallelogram. So we'd get our parallelogram formula and say our parallelogram is base times height. But we have to rearrange that formula a little bit. Look at our base. Our base is base 1 plus base 2 Okay, our base gets turned into base 1 plus base 2, because to make it a parallelogram, we have to go this whole distance. What's our height? Our height was all the way up to here, but it's not anymore. Our height was all the way up to there, but now it's only half of that. So area of a trapezoid, and we're going to write these down when we go to the next page, is half of the bases added together times the height. So still, I mean, it's a little bit of a stretch, but it is still based off of a parallelogram. And that parallelogram just looks half as tall as it originally did, and you have to add your two bases together. Same would be true for this non-isosceles trapezoid. We could do the same thing and cut it off and spin it around. How about a kite? Kite looks like this. I put the diagonals in the kite already. So if you look at that and say, let's rearrange that and make it a parallelogram. Let's not. Let's rearrange that and make it two triangles, which we already know the triangles were based off of a parallelogram. They were exactly half of a parallelogram or half of a rectangle. So we're going to take this kite and say, how do we find the area of this triangle? We already know how to find the area of the triangle, which is 1/2 base times height. Don't write this down. And we also have to take the area of this triangle, which is also 1/2 base times height. We'll look at their base. Their base is right here. They have the same base. But that base is also a diagonal of the kite. If I piece this back together, that's a diagonal of a kite. Where are the other bases? Or where's the height? The height would be this height, h1, plus this height, h2. If I added my two heights together, h1 plus h2, it actually makes the second diagonal. Here was our first diagonal, there's our second diagonal. So we're going to base our kite off of two triangles. But instead of taking the area of the first triangle, the area of the second triangle, and adding them both together, we can combine these two formulas and say, well, one of the bases is diagonal 1, and the other bases, or the heights, combined is diagonal 2. So we don't have to find triangle plus triangle every time. A rhombus, you've got lots of options. A rhombus can be a parallelogram if you measure base times height and you do it at a perfect 90-degree angle, which would be, let's draw it here. If you want to use this as the base and this is the height, or this could be the base and the height, that works. But a rhombus also has the same properties as a kite does, in that its diagonals are perpendicular. So you could also use the kite formula for a rhombus. And a square, you've got lots of options with a square. Has the same properties of a kite, has the same properties of a parallelogram, and has its own properties. So I'll show you on the next page our formulas. Fill this out on your notes. You have a handout. I won't slow down long enough. You may have to pause it. The triangle is half base times height. The rectangle is just base times height. The parallelogram is also just base times height. And you're going to remind yourself that all of the bases have to be perpendicular to the height. The trapezoid is half of the height times base 1 plus base 2. The kite is half diagonal 1 and diagonal 2. The rhombus can be either base times height or the same as the kite. And the square are three options. Could be the same as a rectangle, the same as a rhombus, or you could just take one side of a square and multiply it times itself. Side times side is side squared. You will not need to memorize these formulas. You'll probably accidentally memorize them as you continue to use them over and over, but you'll always have options to the formula. Find the area of, this symbol means parallelogram. Find the area of parallelogram ABCD. If area equals base times height, they were nice enough to draw a perpendicular height in there for you. And you know it's perpendicular because they put the right angle symbol. This 16 and this 16 is down here. This 12 is here. This 10 is here. It's not drawn to scale very well, but this, how do you know what's your base and what's your height? It's the two that are perpendicular to each other. So area equals base times height. Why did they give you the 16? To throw you off. Because some people continue to think base means bottom. Doesn't mean it has to be on the bottom to be a base. It just means that it has to be perpendicular to the height. We could have spun this whole thing. So the area of this is 120. We'll be working on our units. So we'll call this one unit squared since they didn't give us a measurement on it. Okay, you should have this drawn in your handout. Here it is again. Different parallelogram. Still has the side of 12 and 16. But the height this time is different. So these are at different angles. Which are you going to use for the base this time and the height? You're going to use area equals 16 times 9. And you're thinking, but that's not the base. Is it perpendicular? Well, on a parallelogram, opposite sides are congruent. So you have to know that opposite sides are congruent. 16 times 9 is 144 units squared. Next one, how about finding the area of a triangle using half base times height? Sometimes they're going to give you the information, which is super nice. Other times, you're going to have to use special right triangles, 45, 45, 90s, 30, 60, 90s, and trigonometry, sine, cosine, tangent. But sometimes they'll just give you this nice one. With too much information, area equals 1/2 base times height, 1/2 8 times 9. You don't need the 11. We don't measure on a slant. And we get 36 inches squared this time because they gave us the units. I'm whipping through these quickly. Pause it when you need to, especially if you need to draw this if you don't have a packet. This time an obtuse triangle with lots of information. With lots and lots and lots of information. They gave you all three sides of the triangle. They also gave you the height of the triangle. The height gets measured on a perpendicular. Okay, you measure that 12 from the very top of the triangle to the very base of the triangle. Top to base. You could have drawn that same dotted line right through the middle of it if you wanted to and made how tall it is. Doesn't matter where it's drawn, it only matters that it's perpendicular. What's the height? 12. What's the base? 19. You don't need to know this little piece right here. The base only goes from here to here. Area equals 1/2 times base times height for an area of 19 times 6, probably about 114 centimeters squared. Okay. Next up, find the area of that triangle. Find the area of that triangle. You've got a base and you have a hypotenuse, but you don't have a height. Looking for the height. You need the height to be able to do the triangle. So we're going to have to do a squared plus b squared, but noticing I'm calling it h right away so that I know what I'm looking for, equals c squared. H squared equals 25 squared minus 20 squared. No, you can't take 25 minus 20 and square it. You're going to have to take 25 squared minus 20 squared equals 225. And the square root of 225, I bet you, is 15. 15. So once you find out that the height is 15, then you go back to your formula that the area of that triangle equals 1/2 times the base of 20 times the height of 15, which equals 150. No label on that one, so we go with units squared. Notice I'm labeling it every time. Hang in there, there's a lot today. Rectangle, easy, base times height. 25 times 3 is 75. No, take a look at the units. Base times height, we have a base of 25 inches and a height of 3 feet times 12 inches in a foot, a height of 36 inches. 25 times 36 is 900 square inches. How about the trapezoid? But the trapezoid, they're giving it to you on a grid, so we have to find our own height, base 1 and base 2. It's not so bad. They put it nice and straight. They didn't draw it crooked on your graph. So count how far is the base. 1, 2, 3, 4, 5, 6, 7, 8, 9. How far is the other base? 1, 2, 3, 4, 5. So base 1 and base 2 are 5 and 9. What's the height? You do not have to use a distance formula because it's perpendicular. You can just count from 2 up to 8 or subtract 8 minus 2. 1, 2, 3, 4, 5, 6. Height is 6. 1/2 times 6 times 5 plus 9. You could type it in your calculator just like that, so there's no room for error, no mistake. Or you could take half of 6 is 3, and 5 plus 9 is 14. Either way, you get 42 square units. Again, going quickly, pause it if you need to. We've got 4 shapes left. Find the area of this rhombus. You've got options for a rhombus. You could do base times height, but it looks like this one's more set up for half diagonal 1 times diagonal 2. Makes way more sense. How big is diagonal 1? 40. How big is diagonal 2? 30. Or you could have done 30 times 40, doesn't matter. Take half of that, you get 60 square feet. But what if they gave you a rhombus like this? You don't try to make diagonals out of it. You use the other formula. Holy man, this is a big rhombus. It is 10 miles long by 9 miles tall. If they don't give you a label on everything, then the label is all the same. If this says feet, they're all feet. If this says miles, they're all miles. If they give you a label on both, like this one, pay close attention that they're the same label. So we're doing 10 miles times 9 miles is 90 square miles. Let's finish with the kite. We know it's a kite because of its markings. These 2 consecutive sides are congruent. These 2 consecutive sides are congruent. If that's true, then that has to be a right angle. We need diagonals. They didn't give us any diagonals in this, but we have to have diagonals. We're going to have to use the Pythagorean theorem to find that. We know at least one diagonal is bisected, so we know that's 9 and 9, but we need to find this piece and that piece. Let's find x first, and we can find x over here by taking 9 squared plus x squared equals 10 squared minus 9 squared from both sides. You get x squared equals 19, and square root of 19. Don't round this, not yet. This is the square root of 19. Over here, we need to find y. We'll find y by taking 9 squared plus y squared equals 15 squared minus 9 squared from both sides. Need a calculator for that one. just to make sure. You'd hate to make a mistake back here. Y squared equals 144. Square root of that, y equals 12. So we need 1/2 times diagonal 1, which is 18, times diagonal 2, but we can't add those together as they are because one's a radical and one's not. And if you're going to round your answer, you can't round it here, type it all in, and round it again. You have to finish it like that. Try this on your calculator. Make sure that you properly use the square root button. You do 0.5 times 18 times parentheses 12 plus the square root of 19. And you should get 147.2 for the area. And this one is inches squared. Last one. I know, I said it was long notes. Same thing here, but you've got 6 decimeters and 6 decimeters. You've got an 11. The only piece you need is right here. You're thinking, wait, how am I going to find that piece if I don't know how long those sides are? Take a look at it carefully. This is not a kite. It is a rhombus. How do we know it's a rhombus? Because all 4 sides are congruent. If all 4 sides are congruent, it's a rhombus. One of the properties of rhombuses is that diagonals bisect each other. So you don't need the Pythagorean theorem. You can just do half of diagonal 1, which is 12, times diagonal 2, which is 22. And you should get an area of 132 decimeters squared. Okay, the difference there between here is one's a kite, one's a rhombus. Same formula, but much easier to find. That's all. Just 22.5 minutes worth of notes. Good luck.